All right, geometry, we're going to continue into proofs and lesson 10. So proofs with constructions, that means we're going to add some auxiliary lines, possibly add some parallel lines, etc. Okay, opening exercise. So in the figure to the right, segment AB is parallel to segment DE, and segment BC is parallel to segment EF. Prove that B equals E. So our hint is extend segment BC and segment ED. So I'm going to go ahead and do that. A straight edge would be a really good idea if you have one. All right, let's look at our proof. So the first thing we have to write down is what is given. So I've got segment AB is parallel to segment DE, and BC is parallel to EF. And that is given. Awesome. What else do we know? Well, first I'm going to add a little z here. And we see that if I have a parallel line here, and a parallel line here, and a transversal, we know that z is equal to E. So let's write that down. And my reason is alternate interior angles are equal in measure. I'm going to use this reason again, so it's taking up a lot of space, but it's all right. All right, let's look at this again. So we just did these two parallel lines and this transversal. This is alternate interior angle. Now let's look at these two parallel lines and this transversal. And I also have alternate interior angles. So we have Z is equal to B. And that's the same reason for both. Now I can very easily say that B is equal to E. And they call this the transitive property. But they haven't explained this one yet, so I'm going to add a slide here in a minute to talk about that. It's easy to get this one confused with substitution. And we're done, but hold on. Transitive, spelling error. Property. Basically, it just says, I mean, if you did it for angles, it would be if angle A is equal to angle B, and angle B is equal to angle C, you could say that angle A is equal to angle C. Okay, I always found that if the middle matches, then the ends are congruent, and that's your transitive property. You could say it with segments. Segment AB, this is just a random, is equal to segment CD. Segment CD is equal to segment EF. So you can say that segment AB is equal to segment EF. Okay, it works for anything. If your middles match, your ends are equal. Okay, let's go through this one together too. Drawing or extending segments, lines, arrays, referred to as auxiliary lines, is frequently used in demonstrating steps in the deductive reasoning process. once segment BC and ED were extended, in the previous example, it was relatively simple to prove the two angles congruent based on our knowledge of alternate interior angles. Sometimes there are several possible extensions or additional lines that would work equally well. Okay, so that's really for the previous example. For example, in this diagram, there are at least two possibilities for auxiliary lines. Can you spot them both? So I'm going to spot them, and then we're going to erase it and start over. So here I want to prove that z is equal to x plus y. Okay, I can draw an auxiliary line here that is parallel with the other two. Remember, then we can label these like A and B, two other random names, and prove that A is equal to X and B is equal to Y, and A plus B is Z. So if these two are equal and these two are equal and these two add up to this one, then you can say these add up to that one from substitution. Let's erase all of that. And that would work just fine. But you could also extend that line down. That's an awful line. It gives us another transversal. So this would be x. Okay, because they are corresponding angles. And this would be y. Because they are vertical. And then z equals x plus y because the exterior angle is equal to the sum of the opposite interior angles. So you can pick either one. And I talked through the proof, but we're going to go ahead and write it down. All right, let's do this one first. Excuse me. And we're going to name this V and this W. All right. Let's put down what's given. So in the proof, we do have to state what's given. AB is parallel to CD, and that is given. What else do we know? Doesn't matter what order. I'm going to go ahead and say this one first. Angle Z is equal to V plus W, and my reason is, exterior angles are equal to the sum of the two opposite interior angles. So we have that. We can also say that x is equal to v. This one goes there. And we know x is equal to v because they are corresponding angles. And we can say that w is equal to y because they are vertical angles. And then we can substitute z, keep my color, z is equal to, instead of v, we're going to write x, and instead of w, we're going to write y. Substitution. Sorry for the delay. Substitution, property of equality. Okay, let's do this one again. Okay, so this time we drew that auxiliary line through angle Z. And like I said before, what we're going to do here is prove that x is equal to v, I think I labeled it A, and y is equal to w. So v plus w equals z, and then you can substitute and say x plus y equals z. So let's go ahead and write it. I have more room this time. Segment AB is parallel to segment CD, and that is given. And now we can say that x is equal to v. Let's make that a little neater, sorry. X is equal to v, and then I'm also going to say that y is equal to w, because they're the same reasons, and that is my corresponding angles are equal in measure. And I can also say that angle Z is equal to V plus W. And my reason is the angle addition postulate. And then I can say that Z is equal to X plus Y. And it is the substitution property of equality. Nice work. Okay, some more examples. In the figure to the right, segment AB is parallel to segment CD, and segment BC is parallel to segment DE. Prove that the measure of angle ABC, right there, is equal to the measure of angle CDE. Okay, I'm going to talk through it again because proofs, a lot of examples just help you sort of figure it out. Okay, so let's write down what's given. AB parallel to CD and BC parallel to DE. So if I take this, okay, if these two lines are parallel, and this is my transversal, I can say that, I hope I can't. So first I'm going to look at these two lines are parallel. Here's my transversal. So this is congruent to that. So I'm going to write that down and then erase my drawing. So angle ABC is equal to, the measure of angle ABC is equal to the measure of angle BCD because of alternate interior angles are equal in measure. Cool. Now I'm going to look at this, these two parallel lines and this transversal and say that this angle is equal in measure to that one for the same reason. So I have the measure of angle BCD is equal to the measure of angle, whoa, I really messed up my drawing, CDE. And that is actually for the same reason. Now we're going to use that new transitive property. To give you a visual, ABC is equal to BCD, BCD is equal to CDE. If the middles meet or match, then the ends are equal. So let's write that down. The measure of angle ABC is equal to the measure of angle CDE because of the transitive property of equality. Okay, another one in the figure to the right. Segment AB is parallel to segment CD. Segment BC is parallel to segment DE. Prove that B plus D equals 180. Okay? Let's see what we can do here. Just staring at it for a minute. It looks like I have two parallel lines and a transversal. So I can actually say that this angle plus this angle equals 180. Let's draw that a little bit. So I have two parallel lines and a transversal. So I can say that this angle plus this angle equals 180. Then, if I look at these two parallel lines and this transversal, I can say that this angle and this angle are equal because they're alternate interior angles. So this plus this equals 180. These are equal. I can substitute to get to this plus this equals 180. Let's go ahead and do it. Erase my drawing. All right, let's write down what we know. AB is parallel to CD, and BC is parallel to DE. And that is given. I should label that little angle in there. Let's give it a C. That's a C, not an E. All right, let's say C plus D equals 180. And my reason is same side interior angles are supplementary. And then I can say that, oh, I missed my color coding, sorry. We can say that B is equal to C because alternate interior angles are equal in measure. Cool, and then I can substitute. B plus D equals 180. Substitution, property of equality. Okay, last example to go through with you guys. In the figure to the right, prove that D equals A plus B plus C. I think I'm going to need to split this thing up into some angles to give myself a few triangles. So I'm going to split this up here and maybe give you guys, that was awful, a few pointers and see if you can do it on your own. Goodness, I would use a straight edge. I can't on my iPad though. Awesome. So let's see, what are we going to do here? Let's label this angle Z. I'm just going to give you a few pointers. And it looks like I can do D is equal to A plus Z because of the exterior angle is equal to the sum of the two opposite interior angles. Then, oh, I have another exterior angle is equal to the sum of the opposite interiors. Z equals B plus, that's awesome. B plus C, same reason, the sum of the opposite interior angles is equal to the exterior angle. Then it looks like I can do a little bit of substitution to get to D equals A plus B plus C. Okay, so I'm going to erase all this, and if you could try to write it out on your own, it would be very helpful to you. So I'm going to push pause. All right, there we go. It was pretty simple. All right, in closing, how do auxiliary lines help solve for unknown angles? So sometimes extending a segment, a line, or array, or simply adding a line, it sort of shows you an intermediate step in a solution to an unknown angle problem or proof. We had parallel lines. We had, parallel lines. This is where we added this to give us a transversal. There were lots of options, but either finishing off a triangle or splitting up an angle or connecting things just helps give you an intermediate step. Good job today.